All right, in this video, we are going to solve this sine law word problem over here. And this is an ambiguous case question. So I'll just go through the question really quick to begin with. A triangular plot of land is enclosed by a fence. Two sides of the fence are 9.8 meters and 6.6 meters long. The other side, which is the unknown side, forms an angle of 40 degrees with the 9.8 meter side. So when reading this question, I'm going to note down this information in my paper, but we have two sides that are 9.8 meters and 6.6 meters, and we have an angle of 40 degrees with the 9.8 meter side. And remember, this forms it with the unknown side as well. So generally speaking, when we have two sides and an angle, the first thing we need to determine is whether it's sine law or cosine law. Now we know in this case that if I had these two sides and the contained angle between these two, it would be cosine law. In this case, this is not the contained angle between these two sides, which means I'm going to solve this with sine law, which means that ambiguous case is always a possibility in this question. Anytime I have a sine law with two given sides, I always start by drawing out an acute triangle. I just draw the acute triangle like this always. You don't have to do it like this, but I find it helps to have it a bit consistent. And then I'll also draw an obtuse triangle right now, but we're not going to need this till the third part of this question. So not quite too much about, oops, I drew that wrong as well. The obtuse triangle is supposed to be like this. Again, lots of different ways you can do this, but here's how I prefer to do it. So I have my two possible triangles over here. I always start working with the acute triangle given an acute angle. So I'll always label these as the given angle on the bottom left. Again, just because it's easier for me. You could put it anywhere you want and then solve based on that. But like I said, I find this easy. Now, again, the question said that the unknown side, which I'll always keep the bottom as the unknown side in both my triangles. The unknown side and the side with 9.8 meters forms the angle of 40 degrees. So I'm going to label that in both my triangles as well. And then the other side is 6.6 meters long. So this is how I'm going to start labeling out both my triangles for the ambiguous case. Now I simply have to solve the questions. This is a sketch of the situation, by the way. You can label the bottoms like X and Y if you want, things like that if you want as well. Label it X and Y for now, why not? And the question says to find the height of the triangle to the nearest 10. Okay, so if I want to find the height, it doesn't matter if I use this triangle or this triangle, they both have the exact same height. I'm just going to use this one over here. It's a bit easier to visualize it and draw it on this one. But even if you use this one, you'd get the exact same answer. That's my height. So this is a right triangle over here. I'm going to use SOHCAHTOA to solve for this right triangle. So I'm going to do opposite over hypotenuse. So sine 40 equals to h over 9.8. I'll cross multiply this over. 9.8 sine 40 equals to h. Which is 6.3 meters is the height of this triangle. Now that we found the height of the triangle, the third question asks us to find how many lengths are possible for the third side. So remember, for the ambiguous case, the answer is always 0, 1, or 2. There's either 0, 1, or 2 possible lengths for the third side. It only asks us how many lengths are possible for the third side. It doesn't actually ask us to find it. And using the textbook, there are a couple of rules that you can memorize. I'm going to show you this really quick. You can memorize these. They should be in any textbook of the ambiguous case. But basically, if you memorize these for acute and obtuse triangles, you should be able to answer that question. However, I don't like using these rules because I find they're a bit excessive to memorize and they're kind of pointless. So rather than use those rules, which are definitely a lot quicker, I just actually solve both triangles to see whether the third side is possible or not in each one. So let's solve for the third side. Let's solve for the third side over here in this first one. I'm going to start by finding this angle here by using my sine law. So sine 40 over 6.6 equals to sine theta over 9.8. And then I'll cross multiply the 9.8 over. And I'll put this in my calculator. 0.9544. And then I'll do the sine inverse of this to find theta. So theta, I'll round it to a whole number, is 73 degrees. Can do 180 minus 73 and 40 to find my third angle, which is 67 degrees. And now again, I can use sine law to find x over here. So x over sine 67 equals to 6.6 over sine 40 using my sine law again. I'll cross multiply this over. So 6.6 sine 67 over sine 40. And 6.6 sine 67 over sine 40 is 9.5 meters. So that's definitely possible. So the first triangle is 100% possible. So we definitely have one possible length for the bottom side. Let's go to the second triangle here. To solve the second triangle, I always start by finding the obtuse angle by doing 180 minus 73, which is 107 degrees, and then 180 minus 40 minus 107 is 33 degrees, which means the second length is possible as well over here. Even though I haven't found it yet, it's definitely going to be possible. So y over sine 33 equals 6.6 over sine 40. I'll cross multiply that over 6.6 sine 33 over sine 40. And then I will get 5.6 meters. So two possible lengths, 9.5 meters or 5.6 meters for the base of this triangle or the final side of this triangle. If you did not want to really use that and you want to use the laws in this triangle, we know that the height is, we found it to the height to be 6.3. If the height is less than the side that you know that's opposite the angle you know, which is also less than this, basically if h is less than a, which is less than b, where a is the side opposite the angle that we know, and b is the other side. If this statement is true, you can automatically state straight away that two triangles exist based on this proof. We know that 6.3, which is the height, is less than 6.6, which is less than 9.8. So if you want a quick solution, you could just use this law. However, I don't like to do that. It may be required in your class, but I prefer to do all the steps here to find the possible lengths and then state, therefore, there are two possible lengths and two triangles exist in this case. If you made it to this end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.